All right, so 2.3 deals with finding domain and range. So we'll start with looking at graphs to find the domain and range and stuff like that. And then we'll look at actual functions, okay? So for this first one, I'm going to bring down a little graph here. And this has, 7 points on it. So they want us to look at this graph. So for the graph, so for A, they want us to find f of a -6. So what they mean by this question here. So for this one, they want us to find the y value that corresponds to the x value of -6. So they're saying -6 is the x value, and they want to know what is the f of -6, which is they're looking for the y value. So what we want to do is come find -6 on our graph. So let's see, there's a center. So -1, -2, -3, -4, -5, -6. So I'm at -6. And what I need to do is find that y value. So the point corresponding to -6 is my top left corner. So I need to find that y value. So if I go straight across, it looks like I'm at a y value of 5. So my first answer would be 5. So they're going to give you an x, slide along that x-axis, and then go up and find the point, okay? So B on this one, they want to know the domain. And then they say use a comma to separate the answers as needed. Well, remember, when they want to know the domain, they want to know all x values. Now, they're going to give you the fancy little parentheses. All we got to do is put in all of our x values. So the first point here has an x value of -6. The second point come down has an x value of -5. Third point come down has an x value of -4. So I'm just going straight down from my points to see what those x values are. My next point goes straight down, has an x value of -3. So it looks like I'm just going to the right by 1 on all these. This one comes straight down, has an x value of -2. My next point, x value of -1. And then finally, my last point on the y-axis, well, if I come down, that's at 0 on the x-axis. So for my domain, I just went through and seen what all these x values were of these 7 points, okay? All right. Now, C to me is the opposite of A. A, they gave me the X and they wanted me to find the Y value. On C, they want to find any X values for which f of x equals 3. So y'all, for this one, I'm looking for x values for which f of x equals 3. So what they want me to do is find the x values that have a y value of 3. Okay, so they're saying f of x. Remember, f of x is y is the same thing. So what x values have a y value of 3? All right, y'all. So I got to find 3 on the y-axis. So here's 1, 2, 3. So 3 is right here. So I need to find any points that are on line with that 3. And y'all notice I got 2 points. I got this point and that point. So both of these points have a y value of 3. So I need to know what these x values are for these 2 points. Well, this one had an x value of -4. And then this point, if you come down, what's that? Looks like it's a -2. So usually on that part C, you're going to get 2 x values because these graphs are always sort of V-shaped like that. The only one that would have one x value would be this point right here. It's the only one that has a y value of 2. Both of these have a y value of 3. Both of these had a y value of 4. And both of these had a y value of 5, okay? And then finally, the range is so up here the domain was all the x values. Well, y'all, the range is all the y values. Now they're giving me the parentheses again, so I just need to find out all the y values. So the lowest point here, let's see, that had a y value of what? 1, 2. So my lowest point has a y value of 2. The next 2 points both have a y value of 3, but we don't have to put it in there but one time. Although they both had a y value of 3, we only need to put it in there once, okay? So then I go to these 2 points. They both have a y value of 4. And then y'all, the final numbers in my range are the 2 top points, and they both had a y value of 5. Okay, so notice on the domain, I had 7 different x values. Okay, but on the range, I'm only getting 4 numbers because I had 2 3s, 2 4s, and 2 5s. Okay, so we don't put repeats in our range. Okay. All right, so they'll give you this graph for problem 1. And then let me go to problem 2 for us. Now, problem 2 is going to do the same thing. They're going to give us a graph. But notice this time it is actually drawn lines on this one instead of the dots. But y'all, they're going to want the same things. So the first thing they want, so for the graph, A, they want us to find f of 2. So remember, when I say find f of 2, I'm giving you the x value of a 2. So what I want to know is what y value has an x value of 2. All right, y'all. So we need to find 2 on the x-axis and go up and see what the y value is, okay? So here's 0, 1, 2 is right here. So I'm at x equals 2, so I'm going up my graph, and I need to know what that point is right there on the y value. All right, y'all, so here we go. Looks like we're at what? 1, 2, 3, 4. So that point is 4 high on the y-axis. So that answer will be 4. Okay. All right, I keep getting people in. Let me let this one in. All right, then they want us to find the domain. So this will be a new one for you, new lingo for you. But y'all look at this. The x values, this graph goes to the right forever towards infinity. This graph is going to the left towards what we call negative infinity. So since the x's go to the left and to the right, as far as they can go, we say that this domain is all real numbers. Okay, because it covers the negative x's and all the positive x's. And notice these are solid lines, okay? So if you got solid lines like that, those things are going forever. And we represent that in this section as all real numbers. All right, y'all. For C, they want any x values for which f of x equals 1. So remember, they basically want to know what x values have a y value of 1. So that means we got to find 1 on the y-axis. So here's my y-axis, up and down, remember, and that'd be my x. So they said had a value of 1. So let's find 1 on the y-axis is right here. So I'm going to go across. Looks like this point right here and this point right here. They're both on the 1 for the y-axis. So what I now know is, what are them 2 x values? We know this first one sitting here at 5. And then this second point right here is at 7. So at the x values of 5 and 7, my y values were 1 for both of those. And then y'all remember the last one will be the range. So they want to know the range. Now remember, the range is my y values. So here's the question on that one. Now the arrows are going up in both directions towards what we call positive infinity. But I can't do like the domain. I can't call that all real numbers because these negative y values, there's no graph down here in the negative y values. It looks like the range is all these positive numbers. So when you got something like that, the range will be the y values such that, so that means such that that bar So it's going to be the y values. Now, what do I know about these y values? What's the lowest y value that I have, y'all? If you're sitting on that x-axis, what's your y value?
0.
0. And then it looks like it's going up towards what we call positive infinity. So for this one, you would put y such that y is greater than or equal to 0. Okay, so notice the difference. On the domain, it went both directions, positive and negative. But for my range, this graph only goes upward and it does not come down, okay? So y'all, that'll be the first two. They're going to give you the graph with the dots, and then they'll give you the graph with the lines like this one, okay? And they're just trying to give y'all more experience with the domain and range stuff, okay? And y'all, that'll just break us in for what's coming up. Because what we're really worried about in this class is finding the domain of a function. So the thing about the domain of a function, to be in my domain can only be x values that when I plug them into the function, I get a real number output, okay? So when finding the domain of a function, the domain must include all x values that produce a real number when substituted into the function. Now, there's only two things we're worried about at this point. One of them we won't see till later on in life. But there's two types of numbers we're looking for. Things that give us what we call undefined numbers and things that give us imaginary numbers. Now, we won't mess with imaginary numbers right now. What we're worried about in this section is anything that would produce what we call undefined numbers, okay? So, do y'all remember what makes the number undefined? So, we are only worried at this point with any x values that might create undefined. So what makes something undefined? And I will say this, it has to deal with fractions. What would make a fraction undefined?
If it was over 0.
Numbers over zeros, perfect. So y'all remember, I cannot have a number and divide by 0 If I got a number divided by 0, this gives us what we call undefined. Okay? I can divide by any other number in the world. I cannot divide by 0, okay? And if you take your calculators and you try to divide by 0, it will tell you an error message, division by 0, okay? So that means the only way you're going to get something undefined is if you got a fraction, okay? So for the section we're looking at, we must exclude any numbers from the domain So we must exclude any numbers from the domain that create a 0 in the bottom of a fraction. Okay. In a fraction is the only way I can get something undefined. That means for all functions that do not have a variable in the denominator, so for all functions that do not have a variable in the denominator of a fraction, the domain is all real numbers. So here we go. We got to exclude any numbers from the domain that create a 0 in the bottom of a fraction. But for all fractions that do not have a variable in the denominator of a fraction, the domain is all real numbers. Now, if you do have a fraction, so if we got a fraction, what I do? The first thing I do if I have a fraction, I'm going to take the denominator and set it equal to 0. Because y'all, if I set that denominator equal to 0, I can solve it for x values that make that happen. So solve for the variable. And then exclude any solutions. Okay. So remember, I'm going to look at these functions. If I don't have a fraction, it's going to be good for all real numbers. If I do have a fraction, I'm going to see what the bottom takes to make it equal 0. And then I will exclude that number out of my domain, okay? All right, y'all, so let's play with some of these. All right, now these problems, starting at 3, they're just going to say, hey, find the domain of the function. And I think there's like 6 doing this, and then we'll look at the 2.4 support. All right, so the first one I got. This will be like y'all's number 3 here, okay? They're giving me f of x equals 10 over x plus 15. Well, y'all, guess what? I do have a fraction. So since we have a fraction, remember, the denominator cannot equal 0. So we got to find the x value that'll make this bottom equal 0, okay? So what I'm going to do, I'm going to set x plus 15 equal to 0 and solve that. So I'll write it on the side. Since we have a fraction, we need to set the denominator equal to 0 and solve. Well, y'all, there's only one move to do to that. I only got one x down here, so I'm only looking for one number to exclude. Later on in life, if we get an x squared, when we learn our quadratic stuff, if I got an x squared, that means I'm going to have two numbers to exclude and so on. But since this is only one x, to solve that, I'm just going to move that 15 to the other side by subtracting. And that gives me x equals a negative 15. So I got to exclude x negative 15 from the domain, because if I put negative 15 in up here, I get negative 15 plus 15, which equals 0. Well, 10 cannot divide by 0 because that's undefined. So here's how we're going to kick this number out. Now, they'll give you A, B, C, D answers on this. But for this answer, it's going to be x such that x is a real number and x cannot equal, what did we say? We just said x cannot equal negative 15. All right, y'all, but I can put any other number into that x, and it will give me a real number. It might be a decimal, might be a fraction, but I'll get a real number for any other thing I put into that, okay? All right, so y'all with me on these? All right, y'all. Let's try P of x equals 2x minus 10. So let's think about this one. What do y'all think this domain is? I got a P of x equals 2x.
All real numbers.
Perfect. There's not a fraction here to worry about, y'all. So it don't matter what number you put in for that x, you can multiply by 2 and subtract 10. So since there's no fractions here, this is definitely, now the way they say x such that x is a real number. All right, good job. So what about squares? What if I had something like f of x equals x squared plus 7? What y'all think?
All real numbers?
Perfect. Because once again, I don't have any fractions to worry about. So there's no fractions. So I can square any number and then add 7 to it. So that's a good job. So this will be x such that x is a real number. Now, y'all won't have to write this every time. They'll have A, B, C, D choices on those, okay? All right, I got a g of x equals 4 over 5 minus 2x. All right, well, you see what we got. We got a fraction like we had up there at number 3. So since we got a fraction, we need to set our denominator equal to 0. And solve. Okay. Now, I'm going to take 5 minus 2x. So I'm going to set 5 minus 2x equal to 0. All righty, y'all. So it looks like I'm just going to subtract 5 from both sides to get my x's by themselves. So that'll bring our negative 2x down. That's going to equal negative 5. And then we want that to be 1x. So we're going to divide both sides by negative 2. So y'all, these negative 2's cancel, making that a positive 1x. Now over here, we can't really reduce 5 and 2, but y'all, I got a negative divided by a negative. So the negatives will actually cancel out, making that a positive 5/2. So 5/2 is the only number that I cannot put in for that x. So my x such that x is a real number. And x cannot equal 5/2. Hey, y'all, so that's the trick in this section. Find the fractions, set them equal to 0, and exclude those numbers. All right, so number 7, same thing. P of x equals absolute value of x minus 2. Hey, y'all. What y'all think on that one?
All real
So,
numbers?
oh, I think I heard you, but I didn't hear the answer.
Is it all real numbers?
All real numbers, because guess what? I don't have a fraction, so I can take the absolute value of any number and then subtract 2. So once again, there's no fractions. So this will be x such that x is a real number. All right, so that gives me 8. And this one is a p of x equals, ooh, let me turn it up on these exponents. How about a x to the third minus 5. All right, y'all say it out loud.
A real number?
There you go. X such that X is a real number. Okay, once again, this one had no fractions. So y'all, that's 2-3. The main thing was to get y'all used to this domain stuff and the idea that the domain has to be numbers that you can put into these functions and get a real number output, okay? All righty, so not too bad on their college algebra. So now what we're going to look at is 2.4 support. And this just goes over a few things you need to know so that we can do our 2.4 college algebra on Wednesday. All right, y'all, so let me see on my number 1 here. B plus parentheses 4B minus 77. And this is getting you used to parentheses. When a parenthesis has a plus in front of it and no number, by the parentheses, we treat it like a +1. And basically, we're just multiplying by a positive, which is not going to change the signs. Okay? So treat it like a 1. So this B would come down. Basically, if they're following a plus like this, you drop the parentheses and everything comes out with the same sign. So that this will be a plus 4B and then minus 77. So instead of it being like a -1, you treat it like a +1. Remember, positive times positive stays positive. Positive times negative stays negative. Now the parentheses are gone. Can I go further with that?
Combine like terms.
There you go. And let's see B's here. So let's see, we got 1B plus 4B. So that'll give us 5B minus 77. Okay. So they're really going to hit y'all a lot in the beginning about like terms. Now y'all watch this one. This one has a 8D minus 3 minus parentheses 2 minus 5D. Now over here you had a plus in front. So when you distributed, everything pretty much stayed the same. Over here you got a negative. So when we distribute that negative, it will change their signs. Because remember, that's like a -1 getting multiplied through. So this D is not in parentheses, bring it down. It's -3, not into parentheses, bring it down. But now you're going to distribute that negative to everything inside these parentheses. So a negative times a positive makes that a -2. And then that negative times that -5D makes that a positive 5D. So notice, I got to get rid of the parentheses before I can start adding my like terms, okay? Because technically, this is multiplication, and multiplication always happens before adding and subtracting. All right, now, so let's add the like terms. The 8D will add to the 5D. So let's see, 8 and 5, that'll give me what, 13D. And then that -3 will add to that -2. So -3 minus 2 gives me what? A -5. Okay, y'all, so that's what they're doing. They're really writing parentheses in this section. All right, watch this one. -8c minus parentheses -6d plus 6, and then plus parentheses 17c minus 8. So they broke out both two sets of parentheses. One's following a negative, one's following a positive. So y'all, does anyone want to tell me what's coming out of all this? Because we're going to have to bring down to -8c. So what's coming out of these two numbers?
It's gonna, you basically multiplying -1 to everything in the parentheses,
Perfect.
the first set of parentheses.
Yeah. So let's see, that -1 times that -6 will make that what a positive 6d. And then your negative times 6 makes that a -6.
Mhm.
All right, so now you got these ending parentheses. So there, we're going to distribute the plus, but it's only like a +1. And remember, 1 times anything is the itself, right? So 1 times 17c will make that a positive 17c. And then the 1 times -8 makes that a -8. So you got to be careful on these as to what signs in front of them, because negatives have the power to change the signs when they come out, okay? Ooh, I got stuff everywhere, so let's see. Well, we can add the c's together. So -8 plus 17. So let's see, 17 minus 8, that's going to give us 9c.
9c
Look
plus
at the
6d.
6d, it don't have no one to add to. So I'm just going to bring down to 6d. And y'all look at that. I got a -6. It'll add to that -8. And that'll be what, a -14. All right, I have no more like terms, so we stop there. All right, y'all, let me ask y'all this. Y'all have heard of the distributive property, right? So number 4 is a -4, and then parentheses 7a plus 10. Now, this is going back to the distributive property, which is basically what we were doing with these negatives up here. We treated them like -1s. But the distributive property here, since I got a -4 in front, we got to take the whole thing, the -4, and distribute that. Okay, so the negative and number get multiplied. So -4 times 7a, that's what, a -28a. And then that -4 carries through to multiply by the 10. And -4 times 10 is a -40. I have no like terms, so final answer. All right, y'all, so watch this one. Now they start throwing that alphabet at you. 9m times n minus p plus a q. So let's see what's happening. I'm going to multiply to 9m. This whole thing gets multiplied through here. And we're distributing it to everybody. So 9m times the n gives you a 9mn. Then you're going to take that 9m times that negative p. Well, first of all, a positive times a negative, we'll keep that a negative. And then the 9m times p is just a 9mp. And y'all, finally, that 9m multiplies by that q. I got a positive times a positive, which is going to keep that positive. And I get what? A 9mq. And I can't combine this any better because I don't have any like terms. So a lot of this is just getting y'all used to that distributing, okay? All right, y'all, let's see what y'all do here. On this one is multiplication. 8c squared times 4c. So y'all, what kind of answer is this going to give me? So first of all, you're going to multiply that 8 times that 4. And let's see, 8 times 4, that's going to give us 32. But what I'm interested in is what y'all give me when I multiply that c squared times that c.
Cube.
Perfect. C cubed. So remember, you treat this c like it's got a 1. And when you multiply a variable times itself, you add those exponents. All right, y'all, we can't go no further because we've done everything we can do, which was that little step of multiplying, okay? All right, y'all, let me turn that over. Number 7 has a 3c times parentheses negative 2c3 d3. All right, so let's think what y'all would do with that.
Negative.
So negative.
Negative 6c4.
Oh my
to the
God,
fourth
perfect.
power.
C4 and then you got one more thing.
D3.
D3, there you go.
Oh, okay.
Yeah, the D3 couldn't change because it didn't have another D to multiply. So really the only thing changing was the numbers. We got the negative 6. And then we had 1C here. So 1 and 3 gave y'all 4 like you did. Perfect. And then since the D3 didn't have a D here to multiply, it just comes down to the N.
So is it still similar to combining like the combining the ones that are like?
Yeah, you can only change exponents when you're multiplying the same variable times itself.
Okay.
Okay. So if I just had say a 3C here and a D here, my answer would just be a CD or whatever. But I can never change different letters into just one letter, okay?
Okay.
So have y'all ever heard of foiling?
First, outer, inner, last.
Perfect. So they review a little bit of foiling for you. Now, really, what you do when you foil, you take the X, distribute it through the second parentheses, And then you take this 2 and distribute it through the second parentheses. Both of these in the first parenthesis get multiplied by both of these in the second. So these last 4 problems are dealing with what we call foiling. So the F is the first one in each parentheses. So I would take this X times X. So y'all, X times X, what are you getting?
X squared.
All right, so I got an X squared. Outer is the outermost. This X times that -3. And that'd be
Negative
what?
3x.
So X times X gave me X squared. X times -3 gave me -3x. So we distributed the X. Now we're going to distribute that 2. So you got a 2 times X, which is a positive 2x. Then you got this 2 times that -3. So that'd be what, a -6. Now notice, FOIL. I did the first one from each parentheses, and then I did the outermost 2 numbers. The I is the innermost 2, so we started distributing the 2, and the L is the last one in each parenthesis. So who can take me further with that?
One X. Wait.
Oh, you're
I mean,
very close.
negative 1x.
There you go. So I got my X squared minus my 1x minus my 6. Usually when you got stuff you're foiling, a lot of times you're going to have like terms that you got to add in the middle, okay? All right, so let me try one like this. 4r plus 5t, and this will be a 4r minus 5t. Y'all see that these are exactly the same except for one's being added and one's being subtracted. These are what we call conjugate pairs. They look the same other than the operation. One will be added and one will be subtracted. So we call these conjugate pairs. Now, when I foil these conjugate pairs, you're going to see something happen on them, okay? And this is only true when you got conjugate pairs. But y'all, let's foil it and see what happens. So how about that 4r times 4r? That is a 16r squared. All right, y'all, I got this 4r times a -5t. Well, first of all, I know that's going to be a negative no matter what. Kind of got a positive times a negative. And then 4 times 5 is 20, so I get a -20. And then I got an r and a t, so that's just going to stay a rt. Now let's see what's happening on the inside. So here comes the I and the L. 5t times 4r, that's a positive times a positive. That's going to give me a positive. 5 times 4 is 20. Now I'm just going to keep the letters in alphabetical order, because a TR and an RT are basically the same thing, okay? But I'm just going to keep them in alphabetical order. And then this 5t times -5t. That's going to be a negative because I got unlike signs. 5 times 5 is 25. And then the t times t is a t squared. But y'all, what I'm wondering about, what happens to this problem? And what I'm wanting y'all to focus on is this stuff in the middle.
It basically
Cancels each other
subtracted
out.
from each other.
Yeah, they basically going to cancel, and that's the thing. When you got conjugate pairs like this, the middle terms are going to cancel out every time. So that my final answer will be that 16r squared minus my 25t squared. And I'll tell you this answer has a special name. When you FOIL these conjugate pairs, these answers are what we call the difference of perfect squares.
Oh, because it's subtracting squared.
Subtracting the difference, and everything has a square root. 16, 25, all them numbers will be what we call perfect squares. So not too bad. You just gotta keep up with signs is the main thing when you're FOILing, okay? And realize the only time I changed the exponents was when I multiplied r times r. I got an r squared and all that fun stuff. Once I started combining terms, I cannot change anything as far as these letters, okay? All right, y'all, they have one that is r minus f times r minus f. So be careful. These are not conjugate pairs because they're both being subtracted.
Mm-hmm.
So people get these mixed up with these conjugates, but they're not. Now, when you FOIL these, nothing will cancel, okay? So y'all, let's go. R times r squared. That r times that negative f is a negative f r. So remember, I'm just keeping them in my order. But now here you got a negative f times the r. So that's going to give you another negative f r. And then at the end, this negative f times that negative f, well, that negative times negative is going to make that a positive f squared. Now, don't cancel those out, y'all, because these are both negative. So that's like a -1 and a -1. So
Yeah.
let's see what that does. We're going to bring down to r squared. All right, y'all, what'd that give me?
-2. I don't know.
-2. And then the FR's got to stay the same.
Okay, I was right.
So remember, when you're adding down here, nothing changes as far as the letters. Only how many we got. And then at the end, we're going to bring down r plus f squared. Alrighty, y'all. x3 plus 7. x3 minus 5. So y'all tell me, what will I get when I multiply this x3 times that x3?
X to the 6.
X to the 6. And then let's see, the x3 times -5 is just a -5x to the 3rd. The 7 times x to the 3rd is a positive 7x to the 3rd. And y'all finally, that 7 times -5 is what, a -35. So I see like terms in the middle. So I'm gonna bring down my x6 in the front. So we got a -5, +7, x3. The x3 will not change. All that's changing is the number. So basically that's like 7 minus 5, which will give me a +2 x to the third. And then at the end, I'm bringing down my -35. So y'all are not bad. You just got to keep up really with signs and those exponents. So the last one they did was this, parentheses, c squared minus 4t squared times parentheses, c squared minus 3t squared. All right, y'all. So on y'all, what is this going to give me? C squared times c squared.
C to the 4th power.
All right. Now you got a c squared times a -3t squared.
-3c squared t squared.
Are you asking or telling? That was good.
That was hard actually. I don't know what to do with that.
No, they're tricky. It's just, and that's what this support tries to give you, these kind of problems that are sort of hairy looking, you know. So
Okay.
all right, so you did good on that. How about this next one? -4t squared times a c squared.
Well, the same. Negative 4c squared t squared.
All right, perfect. And y'all, looks like all we got left is this -4t squared times a -3t squared. We do know that these two negatives will make this a positive. All right, y'all. So what do we got? 4 times 3 is 12.
12.
And then t what?
T squared. Or
Remember,
t
you
to
got
the or t to the fourth.
t to the 4th.
Oh.
Because we are multiplying, so we're going to add those and get the t to the 4th. Now we can no longer change exponents now because we're just adding stuff together if we can. And y'all, looks like our only like terms are in the middle again. So bring down your C4. -3 and -4 give me -7 of the c squared t squareds. And then at the end, I had my what? +12 t4. So sometimes this support foiling is probably worse than you're going to see in college algebra. And it's just getting you used to adding exponents when you multiply, not changing stuff when you add and subtract. Those first few problems were getting you used to the parentheses. So y'all, that is 2-3 and 2-4. Okay, so let me see where I'm at. So questions on those?
So number 11,
Uh-huh.
x to the 6th power plus 2x to the 3rd power, they are not considered like terms because the exponent is different.
Because the exponent is different. So you can add, say, x squareds plus x squareds, and you end up with what, 4x squareds?
Mhm.
You can add x cubes plus x cubes, but if you had something like an x squared plus, say, 3x to the cube plus
Yeah.
7x squareds, if you had something like that, the only like terms are going to be the x squareds. So I would have 1x squared and 7x squared give me 8x squared plus my 3x to the cube.
Okay, and that's why in number 12 it wasn't added together.
Right.
Okay.
Yeah, once
The rest of them. Okay.
you so here the times when I was adding exponents was like the c squared times c squared, and then the t squared times t squared. At that point, that's the only time I had the actual variable multiplying by itself. So that's the only time I could change exponents. And then down here, remember,
That's adding and subtracting.
and when you're adding and subtracting, you cannot change the like term part, okay?
Right. Okay.
Alrighty, also questions over this stuff. It's not too bad. This y'all probably did this stuff if you had foundations of algebra class or something like that.
I have a question. This is my first time being able to get onto Zoom, and it are both the support and our other class. Does it have separate classwork?
No, so what I would do, we don't have much today, so we'll probably finish everything in a little bit. But what would happen, I would run technically till about 7:15 for the college algebra part. And then I would just have y'all start asking questions and stuff for the support lab.
Okay. Okay. I just
So
want to.
really the support lab is just for y'all to use when you got homework questions and something really bugging you.
Okay.
So it's not technically required as long as y'all sort of play with y'all's homework and do it, okay?
Okay. Is
All
it in
right,
the same?
also,
Is it in the same area, or is it like in a different book?
oh, it'll be the same link. I don't even shut this off.
Okay.
Yeah,
Okay.
so I got my meeting set up for the whole 2.5 hours to do the Zoom meeting. But
Okay.
usually if y'all don't have no questions and stuff, I just let y'all go and I'll see y'all the next day.
Okay, then that's fine.
Okay.
See
So this is
everyone.
the point where I'm going to ask y'all any questions.